Hi folks, this is Yusuf Rangwala, Principal Specialist, Global Black Belt Team Asia. I'm going to present to you on Azure Kubernetes Service and the value that it brings to building applications of the future. When we talk about applications of the future, what I feel is that the applications of the future is cloud native. These applications are designed to take full advantage of the latest innovation on the cloud. They are intelligent, they're infused with AI, and they are able to incorporate open source technologies and libraries from across the globe. Cloud native technology is how developers can achieve the agility, reliability, and security that is demanded by the applications of the future. By 2022, more than 35% of all production applications will be cloud native. Now, these cloud native applications are built on top of Kubernetes. They are event driven. There's a lot of AI built into it, and they use DevOps and a lot of automation to make sure that you have your applications running without compromising on reliability and security. Azure helps you realize these benefits of adopting cloud native because it offers the strongest developer experience. It also has the most complete toolchain for you and your container workloads. We also have our VS Code integration via the bridge for Kubernetes that can help you debug your applications when you're building them uh, integrated with the Kubernetes environment. Cloud native application also helps you get the maximum of cloud because our Kubernetes service is fully managed with up to 99.99% of SLA. And then we also have availability zones and regions that can help you go beyond to build your business continuity and disaster recovery strategies. And finally, you do not need to kind of think about whether I should be focusing on agility or security because we have you covered there with with about $1 billion of investment every year in security and probably the maximum certifications with respect to compliance. We have got the maximum, the best security that is available of any public cloud provider. Let's look at why should you go for managed Kubernetes and not a do it yourself Kubernetes. So if you look at a high performance Kubernetes, there are certain traits which are required out of it. Obviously, there's Kubernetes gives you out of the box scheduling. You definitely need affinity and anti-affinity with respect to what is the kind of workloads that you're developing and what is the underlying resources. Like you want certain workloads to run on GPU based resources. You want certain workloads to have a higher memory footprint. You also need good amount of health monitoring with intelligent events coming up, which can tell you how your Kubernetes cluster is behaving, how your application is behaving. You need failovers where in case if a particular resource inside of the cluster fails, it is available automatically. You need on-demand scaling, both with respect to your containers and the underlying virtual the nodes that you have. And then you need networking, and networking would mean how do you expose a load balancer from outside of the world to inside. Two, how do you communicate with other systems that are running on the same network as your Kubernetes workloads? How do you do service discovery? And then finally, how do you do coordinated application upgrades such that you have zero downtime for your applications which are running? So what this indicates that Kubernetes on its own is not enough. While it gives you the platform that can help you build your cloud native applications, you still need a lot of infrastructure automation. You need the underlying virtual machines, networking, storage, and data to be provisioned in advance. You need security, governance, and identity management solutions that can help you secure your Kubernetes clusters. And then with respect to development, you need the entire development lifecycle, whether it is, IDE support, whether it is, deployments from source code repository to building to registry to CI/CD, and then finally the monitoring and debugging facilities as well. So, I mean, if you look at, how complex Kubernetes is you have the API server that you basically send your commands to, which stores the data. And then there are these various schedulers and controllers that can go ahead and provision all the necessary resources for you. So this kind of denotes the control plane. And whatever you need to be provisioned, they would be sitting on agent nodes or worker nodes, as we call it, where these, they would be communicating, checking on health, and then eventually be deploying your applications. So with managed Kubernetes, we take away the complexity of managing the control plane for you. What you have is you only provision the virtual machines, the nodes for your applications, which are denoted as customer VMs, and then we will handle the control plane completely for you, including upgrades, patches, including upgrades of your Kubernetes platform. We also guarantee high availability and reliability. We give you very easy ways of securing your cluster, scaling. We give you self-healing, and then we also give you API server monitoring so that you understand how the control plane is behaving. Now, all of this is available to you at absolutely no cost for you. And then if you want a financially backed SLA, we also give you an uptime SLA so that you are rest assured that we will guarantee the uptimes for you. With managed Kubernetes, it also streamlines the development of these containerized apps. So as we had seen, right, there are a lot of security features that Azure offers in terms of Azure Active Directory, Azure Policies, Azure Security Center, and Azure Key Vault for managing your secrets. You can do that and you can integrate it with the managed Kubernetes offering easily. From development, we obviously give you VS Code integration and Visual Studio integration. We give you integration with almost a lot of source code repositories. And then we also give you integration with CI/CD tools, whether it is our homegrown Azure DevOps or with something like GitHub Actions, or you can go for a third-party CI/CD tool as well. We also have a container registry that you can use for storing your container images. This is available and geo-replicated, so highly available and geo-replicated, so that you need not try to replicate this in case of disasters. And then we also give you support for storing your Helm charts along with your containers. With a managed Kubernetes, we give you a choice of platforms, whether you can bring in AKS or you can go for ARO, or you can also bring in your own custom Kubernetes clusters, and we can manage it via Azure Arc. And yes, I've already talked about DevOps. We give you integration with Visual Studio Code, GitHub, Azure Pipelines, and Azure Monitor. Just going more with respect to how the community is evolved with respect to Kubernetes. Microsoft is one of the top contributors to open source projects on GitHub. We have almost doubled our contributions to open source since 2016, and that's obviously the turnaround that I think the overall industry is speaking about with respect to Microsoft. And if you see, all of these projects are the ones that Microsoft has contributed or open source themselves, whether it is something like an open service mesh or Dapper or Helm or Keda. So you are rest assured that we are not only talking about our service, but we are also contributing overall to the community and driving the community forward. Azure Kubernetes Service is the best choice for a managed Kubernetes service. And why do I say this? We give you, built-in best practices. We offered you multi-level security. We give you a unified management console that is very similar to what you've been using for your cloud. And then we also guarantee operational efficiency for you. Let's see built-in best practices. With AKS Diagnostics, what we give you is, intelligent insights out of the box, which will go through your cluster, understand how the health of that cluster is, and give you actionable insights. Like, hey, you know what, your cluster is having so and so issue. Maybe it's a node health issue. Maybe it's disk pressure. Maybe it's the CPU and memory is not being configured correctly inside of your containers. And we go ahead and highlight those issues to you, so that you can go ahead and start fixing it directly, which means you are no longer doing reactive monitoring, but we do the proactive monitoring for you. And these best practices have come from about 1,000 odd customers that are already deployed their applications, and we continuously learn from it and keep on revising our best practices on top of that. A security perspective, we offer you security at all levels. So whether it is container security in terms of making sure that the container does not have root privileges, you ensure that whatever rights are required in terms of storage network, you can go ahead and give that. To going ahead at the node security, where we will we will apply all the security patches for you, and we can do that automatically as well with our automated upgrades process. To cluster security, where you can use our traditional networking security paradigms, whether it is Azure Firewall, whether it is network security groups, and go ahead and enable perimeter security for your applications. To actually role-based security, where you can extend Kubernetes role-based access control to Azure Active Directory and ensure that whoever has access to it has the right levels of access. And then even if when your containers are talking to other containers or other resources on Azure, they are using the right roles and they have the right permissions to access those resources. You can also encrypt your data that is residing in disk at the Kubernetes node level, either using Azure provided security keys or customer managed keys. And then you can integrate it with Azure Security Center so that we can do runtime monitoring of your security stance of your overall cluster, as well as we can detect vulnerability in your images even before your applications are deployed inside of your cluster. With operational efficiency, we obviously give you auto repair and auto upgrade channels so that you don't have to worry about how frequently, we see that the upstream Kubernetes gets upgraded every 3 months. And by auto upgrade, you can be rest assured that we will keep you up to date with respect to whatever the platforms are. Even with respect to the base images, we go ahead and upgrade those for you automatically. We obviously give you auto scaling, and this is both at the container level, and then when your containers are deployed and you're out of underlying VM resources, we can go ahead and scale your virtual machines, your nodes as well. And then we offer you, a specific facility of virtual nodes, wherein if let's say you have bursty workloads and you only want certain instances of those containers to be provisioned, rather than provisioning an underlying VM, you can directly go and scale to what is called as virtual nodes, which is just that instance of that container running in its own node by itself. This will reduce the startup times and make sure that your application can scale much faster. And finally, with our unified management, first of all, our support is amazing. We have certified Kubernetes support people who are available and can be, you raise a ticket and we can be available extremely quickly with our different support plans. We also give you, a very robust way of governance by way of Azure policies. So we have integrated Azure policies with the Kubernetes platform so that you can define your Azure policies and it can identify and make sure that it governs what gets deployed inside of your Kubernetes clusters. At maybe you can go fine grain at the namespace levels as well. And then we've also integrated with the Azure RBAC, the feature, so that you can use Azure RBAC inside of your Kubernetes clusters. I would also want to talk about how you can extend this to your existing Kubernetes clusters to all of these features via Azure Arc. So with Azure Arc, you can go ahead and use all of the Azure features into your own Kubernetes clusters, and it will just behave like an Azure Kubernetes service just there. To talk about the variety of workloads, what we have observed is we've got customers who are there across the board, whether you call automotive or financial services, healthcare or manufacturing. And we've seen different scenarios of applications being deployed, whether it is machine learning, artificial intelligence, Internet of Things, high performance computing, microservices based applications. So let's look at some of the scenarios. So the top scenarios are, lift and shift, where you can just pick up your existing legacy applications, containerize them and migrate them. You can also develop microservices based solutions and deploy them on AKS. Uh, you can enable a secure DevOps channel via AKS. You can do machine learning and you can do IoT and data streaming workloads as well. Digging deeper into each one of them, let's look at app modernization. So app modernization without code changes would mean you pick up an existing application, containerize it, deploy it to an Azure Container Registry, enable CI/CD, where you deploy your uh, YAML files into your Kubernetes cluster, and the Kubernetes will go ahead and pick up those images from the container registry and get deployed. What this will enable is that your existing legacy application is now deployed on a Kubernetes cluster, and Kubernetes manages the lifecycle for it. So if there is an issue in it and it needs to be restarted, Kubernetes can go ahead and reboot it for you automatically. And plus, if you want to scale it, you can go ahead and just introduce multiple instances of the same. So it's just a workflow of how you go about doing it. You use Azure Container Registry to deploy the applications. You create CI/CD pipelines, and then you have a Kubernetes cluster which is integrated with Azure Active Directory and virtual networks, so that you can deploy your legacy application there. The next scenario is building microservices. Now, microservices essentially would mean that I go ahead and decompose my applications into small independent services, which can individually scale and can be deployed anywhere inside of the cluster, depending on what the requirement is. This also helps in developing them separately because there are smaller focus teams, and can lead to faster development. When you deploy your microservices inside of the cluster, you can go ahead and use VS Code for developing, and you can use the dev cluster to make sure that you are debugging and testing your application code. And then when you check in your source code, your CI/CD can automatically go ahead and build the container images, and then it can deploy those container images as pods inside a Kubernetes cluster directly. Next slide. So if you look at secure DevOps, we know that you need, for secure DevOps, there will be security considerations at each and every aspect of your DevOps cycle, whether it is at build or at release, or even when you're monitoring your Kubernetes cluster. So how do you implement secure DevOps? Is that when you're doing your inner loop, which is local, as soon as it goes into source control, uh, your container image, when it is deployed with Azure Container Registry, it can automatically be checked for vulnerabilities, and only if it passes those vulnerabilities, it will be deployed into your Kubernetes cluster. When it is being deployed into your Kubernetes cluster, your Azure policies will ensure that the necessary restrictions are enabled on that containers, like it does not have root privileges, like it is using the right optimum resources. And when it does that, and you can then decide on whether you want to deny the deployments completely or you only want to audit it. And then all of that will go back into Azure Monitor so that the necessary alerting and dashboarding can be enabled on top of it. Let's look at a new scenario, machine learning. We know machine learning is really important because there's a lot of data processing which is required, and this has to be very quick. So when those machine learning models are being built and developed, you will you should rather be focusing on the models rather than trying to figure out how do I deploy my models and how do I go ahead and kind of infer from it. With AKS, what we give you is we give you an ability where a data scientist creates the model, He can register the model on the model registry, and then you can register the image automatically using the image registry, which is nothing but the Azure Container Registry. Now, when you deploy this model, the image automatically gets deployed into AKS, and then you can start monitoring and using these models and start, kind of deploying or using them wherever you want it. The next scenario we'll use is Internet of Things. Now, Internet of Things means that, I have a piece of code that is in my edge devices, and then I need a way for it to send data back to my server systems very quickly, and my server systems need to scale them. I also need to manage those devices in terms of, upgrades, in terms of, trying to see how they are behaving and monitoring them as well. With AKS, we give you something called as Azure IoT Edge, which will make sure that the data is there uh, from your edge. It is being sent onto Azure, and then our AKS can work with Kubelet, which is uh, via the kubelet, so that it can start managing those individual images which are actually inside of the edge devices remotely from a centralized Kubernetes system. So what you can do is you can have your applications which are in that same cluster or somewhere else communicating with the Kubernetes cluster, and behind the scenes, those communications are going via the kubelet into the edge device so that they are being managed completely. For data streaming, we know that there's a lot of real-time data that needs to come up, and then there has to be some processing based on the window that you've decided. This data needs to be analyzed and insights generated, and they need to be then, put across. Now, for data streaming, there's always a cold path and a hot path, because the cold path is required for future analysis and the hot path is required for some immediate insights, which is there. With Azure Kubernetes Service, you can deploy your ingestion service inside of AKS. You can deploy your analysis service inside of AKS, and you can deploy your processing service inside of AKS. And then what happens is that data from various devices, sensors, comes via API management into the AKS system. The ingestion service will go ahead and save it into a Cosmos database, and then asynchronously also invoke the analysis service for the hot path. And this can work with the likes of Apache Kafka, HD Insight to do some quick analysis, and then go ahead and provide the necessary insights, which can then be exposed to your customers either via app service or via another application which is deployed in AKS. Next slide. So let me quickly go ahead and talk about some of the customers that we have. Now, Azure has thousands of customers who are using AKS. In fact, it's one of the fastest growing compute service on Azure, and we have a wide variety of customers. I'll only talk about two examples here, and the idea is, we have got tons of examples on our customers.microsoft.com, but I'll just talk about two examples. The first example is Mercedes, where their R&D created container-driven cars, which was powered by Microsoft Azure. So when the new age cars, all the telemetry that the car generates, that requires to be sent over to your servers, and upgrades are also required for those containers that are there inside of those cars. Now, traditionally, you always were thinking that these cars will now need to come up at the service center and then you will perform an upgrade. But then nowadays, that's no longer the case. So with Azure, with AKS, what they can do is they can send the telemetry directly from the car onto our centralized service. And then they can also manage all of those containers uh, from a centralized AKS service via the IoT Edge kubelet part. In fact, even when the first time the purchase made, the car starts, there's a registration that happens, and that makes sure that the handshake between the servers and the individual cars is built across. This is a quick look at how the architecture of the solution looks like. So obviously there is a web app which is, you know, The developer creates a new in-car application. This creation triggers an orchestration workflow, which will provision a repo. Now, as soon as a new car is purchased, this repo will go ahead and create a container, and this gets deployed into individual vehicles. This is automatically deployed via CI/CD. And then whenever you start the car, the car's head unit connects to the service, locates the most nearest, container registry or wherever the registry is, retrieves its metadata and starts working. So that's how you build a very efficient, automatic car system. The next example is how an SI, Ernst& Young, accelerates its application delivery and innovation on Azure. Now they have to continuously build software which is for their own customers. So what they wanted to do was standardize on the overall development and create these new solutions faster. What Ernst & Young did was they standardized on AKS and Azure DevOps so that whenever any developer goes ahead and builds their application, they build it locally, they push it to a source control repository, and then from there, automation will kick in and deploy their application directly onto the AKS clusters. And that means the developer does not need to worry about what happens to his piece of code once he has checked it. All the steps after it are automated until the time that he eventually sees his test application coming up. Now, this made sure that this development approach was consistent, and that means there were less errors. It was also it also offered faster development times and agility to your developers so that they were able to complete and finish their projects on time. So to summarize, what Azure Kubernetes Service gives you is built-in best practices, multi-layer security, enterprise support, and unified management. Now, this is fully managed. You can scale to hundreds of nodes. It gives you out-of-the-box compliance, whether it is PCI DSS, HITRUST, FedRAMP. Uh, for India, it is MIDI compliant as well. There is very minimal management overhead for you, for our customers, and you can go ahead and develop. You can go ahead and develop your next generation solutions directly on it. From a technology perspective, it is consistent with the upstream Kubernetes, which means you're not locked in onto a provider, and any upgrades or any updates that happens there comes to the Azure Kubernetes service platform automatically. It's also designed for hybrid scenarios, whether you have deployments which are at edge, whether you want to go ahead and deploy it inside your own premises and manage it via Azure, we can go ahead and do that. And then, there are public and private deployments where if you want integration with your on-premises system via ExpressRoute, you can do that. Now, let me go ahead and just cover a few unique capabilities of AKS. While there are tons of other things, but I'll still cover them. So AKS is built on an enterprise grade secure platform, which means, behind the scenes, what Azure can give you or AKS can give you is Azure AD and RBAC access. We also get runtime vulnerability scanning through Azure Security Center. You can use Azure policies to put guardrails. You can secure your network using our traditional virtual network securities. And then you can also get automated threat protection using our diagnostics and intelligent insights. With Azure Monitor for Containers, we give you a wide variety of telemetry from your containers, from the underlying Kubernetes platform, as well as from the underlying infrastructure, which is hosting the Kubernetes platform. So what we give you is we give you ways to ingest metrics. We also ingest all the logs that are published to the standard output and error consoles. We capture all the Kubernetes logs. We also capture all the underlying infrastructure logs, and we publish them for you. The metrics are available via our visualization so that you can view them directly out of the box. And then we also give you integration with Prometheus. Now, Prometheus is an open source tool for capturing all your AKS metrics. And we integrate such that you can use Prometheus inside of your cluster, and this can go ahead and push all the data that is collected into the Azure Monitor workspace, and then you can start building your traditional dashboards using Azure Monitor. So you have a wide variety of flexibility in terms of what to use for ingesting the metrics and logs, as well as what to use, how do you go about visualizing the necessary thing. And then we also give you alerting capabilities so that you can set up these intelligent alerts on top of it. I mentioned about AKS diagnostics. It actually gives you, uh, you know, it gives you an insight about the common cluster issues, like if there is any CPU pressure, memory pressure, or disk pressure in your cluster. It'll go ahead and tell you that. If there are any networking restrictions or any misses on from a networking perspective, I'll go ahead and highlight those across to you. If let's say you have applications which are using a deprecated set of APIs, Kubernetes APIs, because of the frequent upgrades of Kubernetes, it'll go ahead and start highlighting those across as well. Now let me go ahead and give you first look. So for example, if let's say you want to go ahead and create a Kubernetes cluster, you will need to provision the underlying network, the virtual machines. You have to install a lot of system components like etcd, like the kubelet agents, the entire API server. You also need to make sure that you install the necessary certificates which is required for communication, and then you register your agent nodes with the control plane so that control plane can start managing it. When you're doing it on AKS, it is just one small command, is AKS create, and we will do automatically everything for you. Similarly, you can do an upgrade and scale as well. Let's look at more advanced things like, how do you set up a CI/CD? So you need a Git repo, you build a pipeline, you create a container registry, you create a Kubernetes cluster, which we already saw before, and then you have to configure the build pipeline to push to container registry. You need to also configure the build pipeline to deploy to Kubernetes, and then you have to define a deployment strategy. Need the necessary controls, the secrets, all the management effort is required. Here, you just store source code either on GitHub or Azure repos. You create a project in Azure Pipeline, which is available with out-of-the-box templates. Similarly, on GitHub Actions, there is an out-of-the-box template for deploying to AKS. So this is how we are making Kubernetes easier. And yes, AKS also supports Windows Server containers, which means you can have your Linux-based containers running on Linux nodes and Windows-based containers running on Windows nodes in a single AKS cluster. And they both will be exposing their endpoints. They both can communicate with each other. They can communicate with the outside world, just like you would be doing it traditionally. It is just that now they are all being managed by AKS out of the box. Finally, I'll also talk about Azure Hybrid, where you can go ahead and use, essentially deploy AKS onto Azure Stack, or manage your Kubernetes platform using Azure Arc. And I already talked about Azure IoT, through which you can deploy your individual containers into edge devices and manage them via AKS. Here are some of the resources to help you get started, whether it is looking at what we give you with respect to AKS. We also have Kubernetes learning paths. We have tons of case studies. And then if you want to try and pick up, hear from our experts, we have got lots of videos which are available that can help you get started. With this, I'll conclude my presentation. I hope this was insightful, and I hope this helps you get started with AKS. And feel free to reach out to us in case if you have any questions. Thank you.
Hello everyone. Welcome to the another session on Future Ready Application Summit. I am Shrikant Sridhar, Senior Specialist, part of the Azure Global Black Belt team, heading sales for Azure Cosmos DB across APAC and India. So in this session, I'm going to talk about Azure Cosmos DB, one of the fastest NoSQL database available in the market today. I will walk you through on the features and benefits and capabilities of Azure Cosmos DB and how you can build your cloud native application and modernize your application on Azure Cosmos DB. So let's see about the NoSQL market trends here. If you see the NoSQL gained popularity in the year 2010, and in the year of 2018, the market was predicted to have 2.4 billion market share, and it has grown exponentially. And the prediction to be like 22 billion in the year 2026. And if you see here, the DB Engine's ranking of RDBMS versus NoSQL popularity, the NoSQL databases are definitely gaining more popularity here. The most wanted NoSQL database by professional developers is MongoDB, one of the most wanted document-based database. And if you see the most dreaded database by professional developers is being SQL databases like Oracle and Exadata. And based on this comparison, you can, arrive at a solution that NoSQL databases are definitely gaining popularity, and it is a way to go to modernize our existing applications or build any cloud native applications going forward. So we'll see what are the high-level categories of NoSQL databases available in the market today, and what are the characteristics of NoSQL databases. And if you see on the left side, the characteristics are being non-relational, and it can scale out horizontally, and it's highly schema-less. You no need to worry about having a rigid schema and having a tightly coupled relationship in your databases. And what are the categories of databases available currently? Key value databases like Redis, where you can customer scenarios are using for caching or storing a session data, and columnar family databases like Apache Cassandra or HBase to store some of the complex data structures. And the most popular is the document-based databases, MongoDB being the market leader, where you store the data in the JSON format or BSON format. And finally, the graph-based databases. It is highly for relationship-based database between the entities. So these are the high-level categories of NoSQL databases available in the market today. So today's applications are expected to do more. If you see, the massive amount of data being generated and the real-time analytical needs. So the database has to, scale rapidly and elastically, without impacting the workload, either it is a predictable workload or unpredictable workload. So the system has to scale elastically and without sacrificing the performance. That is the key thing. And also the customer want to do some real-time analysis on the data that is stored in the system. So the database system has to support such kind of analytical integration as well. So these are the necessities where predominantly the customers want to modernize their applications, also migrate their applications to the NoSQL database engines. So Azure Cosmos DB, one of the fastest NoSQL database available in the market today, and it is a unique product from Microsoft with multimodal API support. So what it can offer to the customers? So guaranteed speed at any scale. So it is one of the first product provides the SLA-backed throughput and latency requirements for the customers. And with lots of SDKs and API support, it really simplifies the application ecosystem for the technical community, and it is highly mission critical ready. It can tackle any kind of workload, either it is a predictable workload or unpredictable workload, either it is based on the size, storage, or throughput requirements. It is ready for any kind of big data workloads, and it is a fully managed platform as a service. And there are lots of options for you to choose, being a cost-effective system, NoSQL engine. So when to use Azure Cosmos DB? So Azure Cosmos DB. is ideally suited for applications that require one or more these characteristics. If you see your application ecosystem requires really a low latency or high throughput requirement, you can go for Azure Cosmos DB. And if you want to ingest a massive amount of data from devices, it's a, whether it's a read heavy system or write heavy system, when in terms of your engine has to scale irrespective of storage and throughput, Cosmos DB is a way to go, and it is highly unstructured and schema free. So you no need to worry about managing the connections between the data what you store, and you can easily distribute your data across multiple regions. So if you see any of these requirements existing in your current workload scenarios, you can, definitely go for Azure Cosmos DB. It's not only for building new applications on a NoSQL engine, and if you want to modernize your existing application ecosystem, like if you are running any workloads that is on MongoDB or Cassandra DB or even in other NoSQL engines, you can actually move to Azure Cosmos DB and still get the benefit whatever Azure Cosmos DB is offering on top of it. So going forward, I'm going to talk about the key benefits of Azure Cosmos DB. If you see, one of the greatest feature about Azure Cosmos DB is geo-replication. So you can replicate your data to any parts of the world. Cosmos DB is one of the Ring Zero service available in Azure. So what does it mean? Wherever the Azure data centers are available, Azure Cosmos DB service will be part of that data center. So you can literally replicate your data to any part of the world with a few click in the Azure portal, or with a few lines of code changes in the SDK. So it is one of the unique benefit of Azure Cosmos DB. So with a very few clicks on the Azure portal, you can replicate your data seamlessly to other part of the world. And Cosmos DB as a NoSQL engine, it is a scalable database. It can scale horizontally in terms of storage and throughput. So if you have any spikes in your workload, if you are highly unpredictable about your workload, you can go for Azure Cosmos DB, because it can actually scale for your workload needs without sacrificing your latency. So with the proper setup of your throughput configurations, you can expect a less than 10 milliseconds of latency in your workload using Azure Cosmos DB. At the same time, with the geo replication feature and automatic failure feature, you can get a guarantee of 99.999% of availability, and you will get a multi-master write option as well in Azure Cosmos DB. So instead of having a single region as a write region, you can configure multi-region support, and you can actually write the data wherever the users are available to the particular region with a multi-master support. So Azure Cosmos DB is a unique product, and it comes with lots of multimodal API support. And so what are the APIs that are supported for the developers ecosystem, or core SQL API? So it is the structured query language kind of API support available in Azure Cosmos DB. So any kind of new applications or greenfield applications you want to develop on a NoSQL engine with scalability in mind, SQL API is the way to go. You can choose the API in Azure Cosmos DB. And apart from that, for existing workloads that is running on MongoDB, Cassandra, Gremlin, or Table API, you can choose the relevant API support that is from Cosmos DB, and you can migrate your workloads from on-premises system or from other cloud vendors to Azure Cosmos DB. And in terms of the SDK and language support, Cosmos DB has support for popular programming languages like .NET, Java, Python, and Node.js. So literally developers coming from these kind of programming language background, they will have a seamless transition to Azure Cosmos DB with a quick turnaround. So obviously your time to market is very less when you onboard your application to Azure Cosmos DB. So Azure Cosmos DB is one of the product that delivers a zero downtime with a RPO of zero. with the proper configuration of your geo replication features and automatic failure features. You can literally have no downtime on your application, and it comes with enterprise grade security features. If you see, Azure Cosmos DB is one of the service. I mean, like has lots of security compliance certifications done from the Azure point of view, and provides enterprise grade security features for your workloads. And you can have lots of fine-grained access controls using the RBAC support that is natively supported in Azure Cosmos DB. Finally, Azure Cosmos DB is a fully managed platform as a service. So what does it mean? So most of the management activities will be eradicated. So Azure Cosmos DB is a fully managed service. It can automatically handle all the maintenance activities and updates and patches. So most of your management activities will be eradicated when you onboard your applications to Azure ecosystem. At the same time, there are different billing models to choose from. You can go for serverless option. It is a consumption-based model, and you can go for a provision throughput model, or you can still go for auto scale mode based on the workload, whatever it demands. So we have seen the lots of benefits and features about Azure Cosmos DB, predominantly for any kind of new applications that you can build on Cosmos. I mean, it's not only for the new application ecosystem. I mean, it is actually more suited for any kind of migration scenarios as well. If you see here on the left side, lots of NoSQL databases you can, I mean, bring into Azure Cosmos DB, say, for example, Cassandra, MongoDB, DynamoDB, or Couchbase, or the graph-based engines like Neo4j, Neptune, any kind of workload that you can bring into Azure Cosmos DB, because it is built on the NoSQL and wire protocol, and it is highly compatible with any kind of NoSQL workloads you can bring into Azure Cosmos DB from on-premises system or even from cloud-based systems. At the same time, for the migration strategies, Cosmos DB still support the same ecosystem and tools, whatever you're using for your existing Cassandra or MongoDB workloads. Either it is a Cassandra shell or Mongo shell, Robo3T, any kind of tools and ecosystem, whatever you're using in your existing ecosystem, it is still compatible with Azure Cosmos DB when you migrate your workload to Azure Cosmos DB. So that is the one of the key benefit of bringing your workload to Azure Cosmos DB. So in continue to the migration approach, I want to highlight some of the existing challenges what the NoSQL on-premises system or any other cloud vendor system are facing at this point of time. If you see here, I mean, having a NoSQL workloads on on-premises or IaaS system. So these are the challenges currently most of the customers are facing, predominantly poor performance and a lack of data integrity, and obviously the maintenance and setup. I mean, initial amount of effort to bring in your system and running your system and maintaining your system is a very tedious process. At the same time, it is, I mean, becoming very complex and expensive of running your other NoSQL licensed based products on IaaS or on-premises system. At the same time, managing these kind of challenges is very crucial for time to market scenarios. And that's where Azure Cosmos DB raises the NoSQL bar. So being a platform as a service, so these are the options how we can, I mean, like make use of Azure Cosmos DB to eradicate such kind of challenges what you face in your current on-premises or IaaS ecosystem. So since it is a scalable database as a service, it can actually scale based on your data storage or even based on the throughput without any hesitation. I mean, whenever there is a spike, you don't need to worry about managing any kind of storage or choosing the right amount of hardware or CPU, any kind of such kind of configuration, what you really do in your other NoSQL engines. So this platform will take care those kind of aspects for you. And with the Open API support and lots of SDK support, it really simplifies the application development ecosystem and time to market availability. And it can tackle any kind of big data workload, and it's a fully managed service, and it's very cost effective. So let's move on to see why customers in the real world scenario using Azure Cosmos DB. So I mean, I can summarize some of the top reasons why customers is adopting Azure Cosmos DB. So it is the first and only database with turnkey capability. So as I mentioned earlier, you can replicate your data to any part of the world with a few clicks in Azure portal or few lines of code in your SDKs, and it can actually deliver massive storage and throughput scalability. So it can scale respective of storage and throughput without sacrificing the performance. So obviously it can guarantee financially backed SLA for your latency of less than 10 milliseconds from any part of the region. And if we see any NoSQL databases available in the market today, there will be a two spectrum of consistency model, either strong or eventual. But apart from that, Azure Cosmos DB offers three more additional consistency model where the developer ecosystem can choose from. And apart from that, near real time or real time analytics is a must requirement for any kind of modernized applications. So Cosmos DB with Azure ecosystem integrates well with analytical tools like Synapse, or even for Databricks for running your machine learning algorithm on top of your data workload. So these are the scenarios where, I mean, like customer choose Azure Cosmos DB in their ecosystem to get the greater benefits out of it. So I'll walk you through on what are the real-time use cases where we see lots of traction in customer places using Azure Cosmos DB. So most predominant use cases are e-commerce and retail industry, where, I mean, like geo replication is one of the key. At the same time, running a real-time prediction on top of the data is a must have experience in the retail industry or e-commerce industry, where you want to put your data across different regions at the same time, based on the customer preference and scenario, running real-time predictions on what customer want on the data available. So these are the scenarios where Cosmos DB being used. And not limited to, it is ideal for IoT scenarios where actually like writing hell amount of data from I mean, lots of millions of devices to Cosmos DB, at the same time doing lots of analysis on top of the data that is written to Cosmos DB. So it is ideally suited for IoT scenarios. At the same time, any kind of app modernization, you want to modernize your existing legacy applications, and you want to create micro services applications on top of it, Cosmos DB is a way to go. And running real-time analytics on top of the data using the other services. So where you have the very tight integration with other Azure products as well. And the scenarios for lift and shift of existing workloads from MongoDB or Cassandra workloads on-premises or other cloud vendors to Azure Cosmos DB is other ideal scenario where customers being using Azure Cosmos DB. So these are the industry use cases where Cosmos DB being used. If you see, I mean, like retail and hospitality, e-commerce, or customer 360 profiling and segmentation is most of the scenarios. And even for banking sector, where, I mean, customer 360 profiling is very key. So these are the industry segmentations and what type of applications where Cosmos DB being used in the current world scenario. So it will give you insights about the traction, how Cosmos DB is offering for customers across a wide variety of industries. So in this section, I'm going to talk about how we can choose different APIs within Azure Cosmos DB, because as I said before, Cosmos DB supports multimodal APIs. Either it is a SQL API or Cassandra API for Cassandra workloads, or MongoDB API for Mongo workloads, and Gremlin API for graph-based workloads. So if you have a scenario, you can, I mean, go with the decision tree provided here and choose the right API according to your needs. So if you're modernizing your application and if you want to utilize your development team skills and knowledges on a specific set of APIs, say for example, if a developer ecosystem comes from a MongoDB ecosystem or Cassandra ecosystem, and you want to still modernize your application, build something new on Azure Cosmos DB, you can leverage your team's existing knowledge on Cassandra API or Mongo API, and you can actually build workloads on these respective APIs. Or if you want to try new workloads and your developer ecosystem comes from a SQL world of application development, if you want to have a seamless transition to structured query language, you can definitely choose the SQL API. So that is the core API and adds lots of benefits to it. So your application developers can write SQL based queries to fetch the data and write the data to Azure Cosmos DB. And if you want to modernize application and if you want to build something on a relationship based graph based engine, so you can go for a Gremlin based API support. So this is for the application modernization. And if you have a migrate scenario, you can go to the left spectrum of the flow chart and choose the respective API, whatever you want to choose and wherever you are coming from. So in this section, we'll talk about some of the real-time customer scenarios where customer using Cosmos DB for app modernization or building cloud-native apps on Azure Cosmos DB. At the same time, few customer scenarios where actually customer migrated from existing Mongo workloads or Cassandra workloads to Azure Cosmos DB. So if you see here, customer ASOS, they built a real-time product recommendation engine on top of Azure Cosmos DB. So literally they are handling 15 million customers across globally. So what they wanted from Azure Cosmos DB is less than 10 milliseconds of latency for reads and writes, and it ability to scale across different locations, and instant scalability, and change feed feature that is supported within Cosmos DB. So literally they handled spikes in the workload during the holiday season using Azure Cosmos DB. So they don't need to worry about scaling the throughput or storage requirements during the spikes in the holiday season. So another cloud native scenario is from the top customer Coca-Cola. If you see, Coca-Cola is being a top company, and they have business units across 200 countries, and they wanted to build a application on top of Azure Cosmos DB. It's not only to handle data in size in GB or TB, so it is literally storing data in terms of petabytes from various centers from Coca-Cola, and at the same time they're running real-time analytics on top of the data that is stored within Cosmos DB. So the scalability, geo-replication, and handling petabytes of data is what actually like Coca-Cola really wanted from service, and Cosmos DB is seamlessly delivering such kind of features to the customers. Meeting their market demands. So let's talk about the migrate scenarios where customers are successful in migrating their existing workloads to Azure Cosmos DB. If you see here, Citrix was using MongoDB database for their web portal, literally to handle 10 million Citrix users, and it didn't perform well, and that's the reason they are looking for they were looking for a different NoSQL engine, and that's where they chose Cosmos DB because of their availability and latency requirements. And so once they onboarded, they migrated their application from MongoDB to Azure Cosmos DB. So the requirement of handling millions of users become seamless. At the same time, the automatic indexing features provide some lots of insights to query the data faster. So the next customer scenario is Symantec. So how Symantec onboarded their existing Cassandra ecosystem to Azure Cosmos DB, and why they need such kind of system. So once they onboarded their Cassandra API workload to Cosmos DB, literally they had a 40% of savings in terms of data management activities, and the Cosmos DB provided them features like elastic scalability in terms of storage and throughput, and obviously the geo-replication and the latency requirement were key for Symantec to bring in their Cassandra nodes to Azure Cosmos DB. So these are the top customers. It's not limited to, but we have lots of customer scenarios where customer build their new applications or greenfield applications on top of Azure Cosmos DB based on their features, whatever that is offering in terms of geo replication or elastic scale out on storage and throughput and the performance in terms of less than 10 milliseconds. So I will talk about some of the real-time customer reference architectures where like you can adopt such kind of architectures in your ecosystem. If you see here, how to build a 360-degree customer view or recommendation engines on top of Azure Cosmos DB. As I mentioned earlier, ASOS is one of the customer. They're using for building offline or online recommendations on Cosmos DB. So whatever data that is stored on Azure Cosmos DB being used for building real-time recommendations, and later you can use the TTL feature available in Azure Cosmos DB to move the data to cold storage. At the same time, you can build some offline analytics on top of the data that is stored in the cheaper storage for your customers. So this is the one of the scenario where customers are being benefited how to use Cosmos DB for building real-time recommendations or building customer 360 profiles on Cosmos DB. So in this section, I'm going to talk about building the serverless architecture, or modernizing your existing legacy applications into microservices architecture with the combination of Azure Cosmos DB change feed feature. You can trigger events to build some of the event-driven architecture in your application ecosystem. So there are lots of customer cases where customers are using Cosmos DB for modernizing their ecosystem and building microservices-based architectures. So in this use case, I'm going to talk about building a API layer on top of Azure Cosmos DB. It is based on one of the customer scenario, Telstra. It is one of the largest telco available in Australia, and they built a API serving layer on top of Azure Cosmos DB. And if you see here, they have lots of data that is fed to Azure Cosmos DB via streaming and batch-based data, and having Azure functions as a frontline in Cosmos DB. You can build a seamless API request response model that can benefit your user requirements. So in this section, I'll talk about the seamless integration, what we have with Azure Cosmos DB and Synapse. So Synapse is our SQL data warehousing platform where you can run your analytical workloads on top of the Azure Cosmos DB data. And if you see here, Azure Cosmos DB traditionally store the data in the transactional store. And once you enable the Synapse link feature here, there will be a dedicated analytical store created, and it's a pure columnar store. The data sync will be seamless with a few minutes of interval from your transaction store to analytical store. And with the analytical store, you can connect to Synapse via the Synapse link connector. So the users can perform any kind of analytical on top of our workloads. So the beauty of this feature is the analytical storage. The sync is purely asynchronous and it's free of cost. At the same time, you won't have any kind of impact on your transaction store. I'll quickly walk through about the different billing models, what is available in Azure Cosmos DB. You can choose from. So if you have a moderate workloads and if you want to go with a consumption-based billing model, you can definitely go for serverless. So whenever there is a consumption, there will be billing, and if there are no consumption, there won't be any billing for you. So it is highly suitable for any kind of small to moderate kind of workloads, and recommended for lower environments like UAT or SAT or development environments. And if you want to have a dedicated throughput, you can go for a standard provisioning throughput. I mean, your workload very well, and the predictability of your workload, you can go for this dedicated throughput. So whenever there is necessity, obviously your database workload will have a dedicated throughput from this configuration. And if you are unaware about your workload, you don't know the spikes in your workload, you can go for auto scale mode, so that actually it can scale up or scale down based on your workload necessity. So these are the three different workload models that is available in Cosmos. You can choose from, and it is highly cost effective. I think you got a better understanding about the product Azure Cosmos DB. And if you want to try the Azure Cosmos DB, there are different ways to do that. If you see here, if you want to try the Azure cloud-based services, you can go with creating a Azure Cosmos DB free tier account or free account. You can try it out. Or if you don't want to try the cloud-based services, you can go with emulator support. The emulator support, we have support for Windows, Mac OS, or even Linux at this point of time. So what are the next steps? There are few links given here. You can go through the links and get familiarized about Azure Cosmos DB. At the same time, there are lots of learning material available in Microsoft Learn. You can actually go through the documentation here to learn more about Azure Cosmos DB, or you can go through Microsoft Learn for learning, choosing the right learning path for, knowing more about Azure Cosmos DB. We came to the end of the session. Thanks once again for attending the session. And if you want to know more about the product, you can definitely reach out to me via the LinkedIn URL given here. And thanks again. Take care. Goodbye.
Hello, I'm your host, Rory Preddy, and this session at the Future Ready Application Summit is about Azure Spring Cloud. You can follow me on @RoryPreddy on Twitter, and we're going to discuss Azure Spring Cloud, some of its features, how to get started, and then do a demo. So I work in the developer relations team as Microsoft as a senior cloud advocate for Java. I'm part of the Java at Microsoft team. You can also follow them on Twitter at Java at Microsoft for all Java-related updates. It will come as no surprise that 61% of Spring Boot developers say that they use Spring Boot on a daily basis. And it is one of the highest used application developer frameworks by Java developers. So we partnered with Pivotal VMware to supercharge your Spring Boot applications on Azure. And we looked at what you want from a cloud provider. First of all, you want to build your services independently. Typical microservice dependent services don't really scale that well on cloud. You also want to run in the cloud and be able to take advantage of the elasticity, the scalability, the security, the patching, and all of the real meaty services that make cloud development so enterprise grade. You want to scale services automatically, and you want to make sure that you can set up metrics to scale them via specific schedules or dynamically. You also want to be productive through your application lifecycle. Your development tools need to be aligned to supercharge your applications. And then you can finally deliver the value faster and get time to market. So this is really about how you can supercharge your applications. We're going to go through each one of those sections and look at how Azure Spring Cloud takes advantage and lets you do that. So let's start with the first section of build your services independently. So your microservices are a very popular architecture style, and they're a 12-factor app, and each one of those factors allows you to build applications that are resilient, highly scalable, independently deployable, and able to evolve quickly. So typically you have a client, he connects to a number of microservices, and then you have your developer or DevOps engineer there to maintain them and develop them. Then on top of that, you have a management and orchestration layer to manage all of your microservices. And this is typically your Kubernetes orchestration layer. You front that with a API gateway, which allows you to load balance between the different microservices and also look at a client registry, a service registry, to make sure that you can distribute your services accordingly. So how do you take those microservices and then run them in the cloud? So let's look at a typical Spring Cloud setup. So Spring Cloud is made famous by Netflix OSS stack. It allowed a lot of developers to use Spring services and scale out on their on-premise applications. So in Spring Cloud, you have your API gateway, you have your management and orchestration layer, and then you use the Spring Cloud API gateway, and also a service registry, a config server, and distribute tracing to maintain the lifecycle and the operation of each microservices. Then you can get your DevOps person to maintain the troubleshooting via distributed tracing. You typically use Kubernetes to maintain all of this, but Kubernetes can be a little bit of a headache. It's a bit difficult to maintain. You've got everything such as a scheduler, a controller manager, and you have to manage all of the worker nodes, the actual Docker instances, the pods, the containers there. And so this is a little bit too much for the average development house to maintain. They usually have a Kubernetes admin team. So what Azure Spring Cloud is, it takes the Spring Cloud architecture when you manage your microservices with a service registry, config server, distributed tracing, and it takes away the hassle of worrying about and maintaining a Kubernetes instance. So it wraps it all up there, all of those services, and then gives you tight integration seamlessly to CI/CD, Jenkins, GitHub, and Azure DevOps, automation, your provisioning with ARM templates, PowerShell, and Terraform, and then additionally, integration with Azure Monitor and Active Directory for your security. So we've seen how you run it in cloud. Let's look at how you can scale now your services automatically. So Black Friday really is the main shopping holiday of the year for a lot of organizations. You can see there, people start even in October to look at those specials. You can see that this is the traffic analysis for our customers, the Microsoft Internal Data 2019 and 2020. And then right at Black Friday, they really spike. And then it kind of slows down there, a few more spikes. And then right at the end of December, it really stops. So there is a huge holiday search volume. So you need an approach to be able to do this with your cloud provider. So you want a business strategy that drives utilization of resources, elasticity without reserving capacity, upper limits and lower limits that are under your control, and pay as you go. You don't really want to be able to provision all your resources, pay them over 3 years, and then add a fudge factor of 20%, and then only then can you say, how do I do cost savings? You want to start that idea of cost savings from the beginning of your provisioning and your operations to be able to say, how do I lower costs by using the cloud? So the technical approach to do this, you want to scale your specific apps separately. So you can scale the number of individual app instances on Azure Spring Cloud. You also want to scale differently on weekends and public holidays. So scale down to one instance on weekends. You want to scale differently to holidays. So during the holiday season, you want to override the defaults and have more capacity at your disposal. And then you also want to scale on custom metrics. On app based on CPU, memory, concurrent sessions, you can get a lot of different metrics with Azure Spring Cloud. So here's the auto scaling, and we're going to do a little bit of a run through of the features here. So it's metric driven. You can see there, I'm actually scaling and setting it up on Tomcat global request counts. So that is the current request count, and I'm averaging it out there for a few minutes. So I'm going to scale out when the request count is greater than a certain number, and it's going to increase to 3 of a maximum of 3 servers, and then scale in when the request count drops again. I'm going to decrease to 1. That allows me to actually say under load, then scale up, and then wait and see if the load lessens, and then scale down. It's metric driven, but you can also schedule it. So it will first execute this workflow, and then execute that workflow if this one hasn't been triggered. So this one here can be scaled on specific end dates, days, and a schedule base. You can add quite a few schedules there to see if you can match those conditions. And once you have that scaling there, then you get a run history, an activity log, distributed tracing, and notifications and webhooks to tie into DevOps to run triggers against certain workloads. You can see here, I've got my one instance, which is my base instance, and I'll scale up based on the Tomcat request count. And then I'll scale all the way up on great load, but then scale down once that load is lessened. And you can see I get all of those run histories and those metrics there as it progresses. So how do you be productive through your app lifecycle? Now, developers want a glorious experience when they do that. So we've looked at the process, and we've allowed the developer to really have a wondrous experience in deploying and using the built-in libraries that we supply there. So you can take Maven or a dev tool, and you can integrate it with your CI/CD pipelines to deploy your jar artifacts. So your jar artifacts can go straight through without any changes to your existing apps to your microservices and tie into service registry and then your data services. You can also take your source code and use the built-in VMware Tanzu build service, and that uses build packs to go in, analyze your source code, and create a custom container for you that is highly performant to a microservice there if you don't want to use a jar artifact. And this really accelerates development, allowing you to either deploy a jar or a source code. So this is an example of the build packs here. You can see it uses cloud native build packs and then creates those images there, stacks the image, runtime, dependency layer, app layer, and then adds those layers there and generates that Docker image for you. A little bit of an example of what this looks like. You can see there, I've got AZ Spring Cloud app deploy, and I specify the specifics, and then it analyzes my application for me. And says, wait a second, you're using these kind of services here, and you need these layers for each one of those services, and then builds my container for me. You also get blue-green deployments, which I'm going to show you in the demo. So you get 2 deployments for every app. You can one will receive production traffic, so you can actually swap them out into staging, scales with auto scale settings, and seamless failovers. So you can see in the demo that I'm going to do, I'm going to hit it with 1 million transactions, and I'm going to do live there. I'm going to scale over there and not drop a single transaction. So once you have all of those scaling settings, you really want to do troubleshooting with the application services application map. So this is part of Azure Monitor, and you can see this is Application Insights, and this is the last 24 hours. And this is a demo that I'm going to show you coming up. And in that demo, you can see I use the customer service to log customer requests. And that customer service then will connect to a Pet Clinic SQL database, or it might connect to a JMS queue, and you can get seamless integration for each one of those and drill down into the transaction level, both all the way from the browser right down to the database. So delivering value faster is pretty easy. We've got integration with cloud services using Spring idiomatic libraries. So we partnered with Pivotal, VMware, and we've looked at how and what libraries they need to use. So you can use them, the custom libraries, for monitoring, storage services, streaming services, databases, caching, and we have all of these different libraries. You can access them on spring.io/project/spring-cloud-azure, and all of these libraries, you don't have to write a single line of code. Let's take, for example, MySQL. You don't have to write MySQL code. You just have to import the library into your project, and it will use those idiomatic libraries for you. So this is the next section. We're going to stop and go through the demo. And then in the demo here, we've got a Spring Pet Clinic microservice application. So we've got a customer here who's going to use an HTML site to pull via the API gateway customer information that will take a vet appointment and make a visit. All the time, that is going to use distributed logs using Zipkin logging server, and then it's going to use monitoring for the Azure Monitor, and it's also going to use the Eureka Service Discovery to retrieve the microservices IP and the config server to fetch the distributed config. So here's our demo, and you can see this is the Pet Clinic application, and when I click on owners, it's going to bring back all the owners in the MySQL database. There's George Franklin. He's an owner, and I can click through on George Franklin, and he has a pet there called Leo. I can edit that owner, or I can actually go in and edit his pet and add a visit if I needed to for a veterinary clinic. So how this is achieved is I have deployed all of this onto Azure Spring Cloud. I've got a customer service, I've got a vet service, and a visit service. And that manages all of the data using a MySQL database. I also have a config server, which manages my centralized config, an API gateway, which is load balancers between all of the different services, and a Eureka server that is built into Azure Spring Cloud. Now, using the built-in toolkit of Visual Studio Code, I can actually see all of those microservices deployed on my Azure Spring Cloud instance that I've pre-set up. And I can access those services through all of the toolkit's services. I can scale it, and also I can look at the logs. So I can right-click on the customer service, for example, and go view and stop and start, scale those, deploy, view the properties, and open up in Portal. I can also look at the endpoints for that, which is the URL, which I can access the service. So let's go into the service here and the API gateway and see where it lands up. So if I go access public endpoint, you'll see there that it actually takes me through to my public access of my service. I've also opened up a service here, the customer service, which we're going to use for testing as we progress through that. So this is the customer service here, and I've got it there. You can see it's pulling back all of the different services here, and there's George Franklin with his Leo pet there. Let's look at how that looks on the portal. So here is my Azure portal, and I can access that by going to the Azure Spring Cloud instance view here. And then I can go into my instance here. I've called it Booster RP ZA because I really want to boost my Spring Boot apps. And then I can see my app instances here. I've got all my app instances here. I've got my admin server, my API gateway, my customer service, vet service, and visit service. Now, for my customer service, I've actually scaled that manually to 2 instances. And I'm going to show you how to actually use that in and do a seamless failover for those instances and simulate a staging to production push. So in my customer service here, I can see that under deployments, I've got 2 deployments. I've got a staging deployment, and I've got a production deployment. Now, each one of those deployments has actually 2 servers. So for my customer service, I've actually got 4 servers currently running. Now, how do I determine and what those services are running under? So what resources they're consuming? So if I go into my instance here and I go to my application insights, I can actually go into live metrics for those 4 servers. So let's go into live metrics, and let's filter on the customer service there to see exactly can we determine, are these services under load, and did they fail over correctly when I change from staging to production. So I'm going to change the role over here, and I'm going to choose customer service. And you'll see there, it shows me the load, the request rate, the request duration, if there were any failures, the dependency call duration, which is the database, the exceptions and the overall health. And there's the 4 servers that I have. And you can see there that they're not under distress at all. They're actually running quite smoothly. And they'll upgrade updates very soon here. And you'll see the CPU usage as I start putting load on there. So they're not in any load. You can see there the CPU is nearly 0%. So let's add some load now and see exactly what happens. Let's try to break something. So I'm going to open up my Cloud Shell. Now I've set up my script that it will send 1 million transactions in a very short period of time to the customer service. So I'm simulating load this. So let me show you what my script looks like. And then we can kind of see, can I break this instance here? And then I'm going to do a failover on live to see, can we go over to production from staging and show you, this is really what you want to do in Kubernetes. You've got 2 versions of the system of your application, and you want to fail over there. You don't want to manage the nodes or the pods yourself. You want to have everything that Azure Spring Cloud can do it. So if I look at my script here, you can see there, I've just got a curl for the customer service there, and I'm going to do it 1 million times. So let's actually execute that. So I'm going to go sh script.sh, and I'm going to put a little bit of load on my service here. This is pulling literally the whole database, the MySQL database, as we progress. And we should see the load kind of increasing there. There's the increasing, the dependency rates increasing, the request rate, the request duration. You can see there's still no failures there. The dependency, the CPU is still very stable, but it's raising a little bit there. And then there's my service here, and you can see it's actually adding load. And when I look at the service here, you can see the 2 production servers there. If I just make that a little bit bigger. The 2 production servers there are taking the load. And then these 2 staging servers haven't actually failed over just yet. And at the same time, we're going to make sure that that doesn't actually stop or bring back any errors as we do the failover. So let's show you how you can do that failover. So I'm going to go into my Spring Cloud instance here. It's opening that in a new tab. And I'm going to leave this open here while it shoots 1 million transactions into my instance. And then I'm going to do a live failover from production into staging. So here's my Azure Spring Cloud instance here. And then I'm going to the custom service for my microservice. So let's go into apps, into customer service, deployments, and then you can see there the staging is out of service. So I'm just going to right click there and go set as production. Click yes, and then it's going to upgrade the deployment there. Let's go back into our live metrics and see exactly what happens. Now this is Kubernetes, because it's allocating load now onto each of the instances, and it's going to take that load over. And we really want to see if there's going to be a huge spike in exception rates as it does that, because that'll show that this didn't actually work. We also want to make sure that we don't get any errors in the logs as our clients and customers experience those errors on typically a Black Friday scenario. So we're getting you can see there we've got the default staging. We're going to hopefully get the staging servers there. There we go, 1%. It's picking up some load there. And it's going to do you'll see there as it progresses through there. There we go. And it did a failover. 0 exceptions over that. The CPU is already committed, and we didn't lose a single instance of that. And this is really what I wanted to show you. It is Kubernetes on the background. You can do auto scaling, you can do node allocation, and you get the benefits of Kubernetes without having to worry about any of the admin overhead. So let's stop that there, and let's carry on with our presentation. I'm going to start the slideshow from where we left off here. And okay, so not really from where I left off. Let's go back into there. And we want to go through all the way through the slides that we did there. And we spoke about all the different services. We showed you Kubernetes, the scaling, the scheduling, the development lifecycle, and how to deliver value faster. And then we stopped off at the demo. So I've got some really exciting offers before it. So contact your client, Microsoft client team. You get fully sponsored app assessments and recommendations, a free POC for the following workloads: Azure App Service, Web Apps, Functions, Spring Cloud, DevOps. Please reach out to your account executive to see if these offers are available to you. All of those samples that I just did, you can get through the Getting Started workshop on aka.ms/learn-spring cloud. Cloud. You can also use a Spring Microservices Lab on aka.ms/monitor-java, and then give us your feedback there with a survey. So you can go aka.ms/spring azure. Thank you so much for everything, and I look forward to supercharging your Spring Boot apps with you with Azure Spring Cloud.
Hello, everyone. My name is Patrick Behammer, and I focus on our open source and NoSQL database technologies on Azure. So today I wanted to drill into specifically our open source database as a service offerings and how they can help you build your next application faster. Now, I wanted to start by just acknowledging the fact that organizations have really embraced open source, and it's really hard to find any enterprise today that is not using open source in some shape or form today. And more than 40% of CIOs see it as core to their overall software strategy to get out of the lock-in of proprietary systems and moving to more open standards and open source communities. From a developer perspective, developers also expect us as vendors and cloud providers to play an important role in not just leveraging on open source and support source, but to actively also contribute back to the community. So I don't think that comes as a big surprise. What often comes as a surprise, though, is the level of which Microsoft is engaged with the open source community and the amount of contribution that we are providing back to that community. So if you look at the OSCI contributor index, you can see that if Microsoft is not number one, we're certainly number two, depending on which month or what year you're looking at. So that's probably a bit of a hidden secret in terms of how Microsoft over the last decade or so has really shifted focus to be an open platform for any type of applications, operating systems, or databases that our customers want to use. Now, from a database perspective, we've seen the rise of open source databases over, again, more than a decade. You have databases such as Postgres that has been around for over 20 years that have really risen in popularity as that platform has matured and is now a very viable alternative to the proprietary databases such as DB2 or Oracle or even SQL Server for that matter. Then you have MySQL, which has for a long time been a very well-established database technology, particularly for web developers. And as you can see here from the Stack Overflow developer survey, the majority of developers are very familiar with MySQL. And then Postgres is number two. You'll still see Microsoft SQL Server is still up there in the top 5, but increasingly we see not only open source, but also NoSQL technologies growing very rapidly. When it comes to the preferred databases, again, you see Postgres at number 1, and it's pretty much, a neck-to-neck race with MongoDB, which is probably the most commonly used NoSQL database alternative. Again, if you look at what the industry analysts are saying, Gartner is predicting that already this year, more than 70% of the new applications that are being built using open source instead of proprietary database technologies. And I don't think it will come as any surprise that 3 out of 4 databases will be deployed on the cloud as database as a service over the coming years. Now, on the flip side of that, some of these traditional databases like DB2 and Oracle have really started to fall out of favor with developers and is actually ranked as the most dreaded database technologies amongst developers. And you can also see here on the DB Engines ranking how Postgres has been growing almost exponentially. This is a logarithmic scale, by the way, so the growth is actually much sharper than what it looks in this figure. And that has been very much at the expense of DB2 and Oracle database systems. So with that, I'm moving off slide 2 onto slide 3. So let's talk a little bit more about where we're seeing Postgres being used. So Postgres, as I mentioned, has really become that enterprise-grade alternative for enterprise workloads that are often powered by Oracle or DB2 or even SQL Server. Now, Postgres has been around for a long time, and it's arguably the most mature and advanced open source relational database in the market. It offers proven resiliency, stability, and performance. And what's also very exciting about Postgres is the many extensions that exist under Postgres. Postgres is no longer only a relational database. It supports JSON, for example. It's arguably the most mature geospatial database supporting PostGIS as an extension. And then we have Citus, which is an extension I'm going to talk more about because we're particularly excited about how we're leveraging on Citus to enable you to scale your Postgres databases horizontally. So I'm having conversations about moving mission critical systems in large banks, in large telcos, healthcare providers, and other government customers on shifting their focus and seeing Postgres very much as the future of their enterprise database workloads. Next slide. So I mentioned Oracle. Why is it then that enterprises are turning to Postgres when they're looking to reduce their Oracle footprint? Well, TCO is obviously an important factor of this. You're not going to beat the licensing cost of open source, in other words, free, particularly with systems such as Oracle, which are kind of notorious for being rather expensive. So definitely TCO plays a big factor here. Also the fact that, as I just mentioned, the enterprise grade of Postgres, it's really a database that's ready to take over some of those mission critical workloads. But most important perhaps is the fact that Postgres and Oracle are very similar in terms of the schema, the stored procedures, and the database languages. So what that means is to do a migration from Oracle's PL SQL to Postgres PLP GSQL is a lot easier than moving to a different database altogether. So that reduces the risk and therefore the cost and the time associated with doing a migration. Next slide. If we look at MySQL, as I mentioned, it's already the most commonly used database among developers. And that's particularly referring to web developers. MySQL is literally unbeaten when it comes to powering the world's websites and many of the e-commerce and online transaction sites. It's just an integral and natural part of the LAMP stack these days. Now, a bit of an interesting trivia here is that it was actually the same founder who developed MySQL, who then also went on to develop MariaDB. And as if that wasn't enough, he also developed a database called MaxDB. And I'm proud to say it's a fellow Scandinavian who actually decided to name these three databases after his three children, Me, Maria, and Max. So a little bit of an interesting trivia for your next pub quiz, perhaps. But absolutely, MySQL continues to power the world's websites. Moving to the next slide. So we've talked about some of the open source alternatives that exist today, and you can see with the embracement of open source and the embracement of running those open source databases on the cloud, I don't think it comes as a surprise to anyone that Microsoft, formerly known as the SQL Server Company, has decided to take a very open approach and making sure that we welcome any flavor of database, be it proprietary or open source, to our managed platform on Azure. So yes, SQL Server will continue to be best performant and providing the best cost performance on Azure, but equally your open source alternatives, be that MySQL, Postgres, Maria, etc., are also provided on Azure as first-party citizens. And one important differentiator for us compared to other cloud providers is that we stay true to the community editions of these databases. So they are completely backwards compatible to the latest versions of open source databases in the community. We haven't taken the open source code and forked it into a different database altogether. So that's very important in terms of our philosophy, because we know you are moving to open source because you want to avoid that lock-in. We also have a very rich offering of NoSQL databases under the Cosmos DB umbrella. And similarly, we've taken this open approach where we support open APIs for your MongoDB Community Edition, your Cassandra, and your Gremlin APIs, for example. I'm not really going to focus on the Cosmos side of the portfolio today, but there is a session later on that covers that part of the portfolio as well. So look out for that one. Next slide. And I really think that this is one of the key reasons why Microsoft remains the leader in the Magic Quadrant when it comes to database technologies. If we hadn't taken this open approach, I think we would have probably been falling down and to the left, like many of our competitors have started to do, who haven't fully taken this open approach. So that sounds great then, but what's in it for me? What's in it for me as a developer? Well, what's really in it for you in terms of moving to database as a service is the fact that it's going to allow you to focus on building your application and making your application better and spend less of your time worrying about the operational database tasks. I'm not saying that you're not going to need a DBA. Absolutely, there's an important role for DBAs to play, but you're going to be able to do more of the value-adding tasks, writing the right queries for Postgres, for example, instead of focusing on, have I set up my backups, have I got high availability configured, etc. So the operational tasks are significantly reduced. And then, as I mentioned, the importance of staying true to community open source. You're not going to have to worry about lock-in on the Azure platform. And you can continue to use your favorite tools and your frameworks. And not only that, you can also easily integrate your application and how you're building out your solution with other Azure technologies, be that Azure Functions, Azure Kubernetes Services, Power BI, etc. Once you're on Azure, you can start to leverage all the different cloud native technologies that are available in Azure. Next slide. So what really do we mean by database as a service? I get this question a lot. And database as a service, first of all, is just what I'm referring to as PaaS when it comes to databases. And I think most of you are familiar with this stack of what is your responsibility as the customer versus the cloud provider's responsibility as you move from on-prem to IaaS, where you no longer have to worry about your hardware and the virtualization layer, to moving all the ways to PaaS, or in this case, DBaaS, where we will take care of also the operating system. We will make a lot of the operational tasks, such as how do I enable high availability? How do I set up my backup and my backup windows? All of those tasks becomes really a switch of a toggle or a press of a button. And on top of that, we have some additional capabilities, such as our built-in security and performance tuning capabilities, where literally the platform will tell you if it sees any suspicious activity, or if it sees an opportunity for you to, for example, scale down your database SKU because it's over-provisioned, or change a query because the query could perform better. Now, one of the most common questions that I get from enterprises as they're looking at open source is, what about support? Who's going to support me? This is a community thing. There's no one I can point at that's going to fix my problem. And that's, I would argue, is one of the biggest benefits of moving to open source on a PaaS-based platform, because we are treating this service, whether it's Postgres or Maria or MySQL, as a first-party Azure service, and we will be responsible for providing the support. So you will raise a support ticket for this Azure service just like you would any other Azure service. Moving to the next slide. So why open source on Azure then? Well, I've already talked a lot about the importance that we're focusing on staying 100% open source and not forking our databases. That's number one. The second point is our ability to scale. Through the Azure Cloud Platform, we're going to offer you scalability, and you can easily scale your applications and your databases up to larger SKUs when you need them and back down again when you don't need them. Now, one of the key differentiators for Azure is we're also able to help you scale horizontally, and I'll talk more about that later. And I also touched on the point that, yes, everyone has their favorite database, and we want to make sure that that database runs as a first-party citizen on Azure, but equally important that we integrate really well with the rest of our Azure portfolio. So those are some of the key differentiators. If you're going to go to Azure, rest assured you're going to find the tools and the database flavors that you are used to working with to develop your applications. Next slide. So let me talk a little bit about the different deployment options that exist. And I'll start with the differences between the single server and the flexible server deployment options that we have. These exist both on the Postgres and on the MySQL database flavors. Single server, think of single server as the cost optimized SKU, where you essentially get high availability built into the platform, and it's going to be sufficient for most of your workloads. We've also launched Flexible Server, which, as the name suggests, is providing you with more flexibility. For example, in the MySQL world, we have a lot of gaming customers that need to have very specific and custom maintenance windows. We have enterprises that need higher performance and also better high availability options, including availability zone aware high availability. And that's what we're bringing with Flexible Server. It really is a performance optimized and high availability optimized SKU. Now, if we continue to talk about Postgres, I did mention the extension called Citus. This is a technology that is, again, it's not a fork, it's an extension of Postgres. And Microsoft was so excited using this capability ourselves for our Windows Update service that we decided to acquire this technology. And we now call it Hyperscale. You can still use Citus on-premise and on IaaS, but from a PaaS perspective, we're doing some amazing things with Citus to turn it into a database as a service distributed database technology. And then another differentiator that we have, Microsoft is known to be a hybrid cloud, and that's also true with our open source databases. So with Postgres Hyperscale running on Azure Arc, we're allowing you to take the Postgres Azure capabilities and deploy them in your own data center on top of a Kubernetes cluster. You can even run it on a different cloud. And this is useful where you might have latency requirements or you might have data residency requirements, and neither Microsoft or any other cloud provider have data centers in every single country. So that's a good use case for that hybrid scenario. Next slide. So just to double click a little bit more about what's new in Flexible Server. So what's really new here is the performance. We've done some performance benchmarks and we've seen that the performance can be up to 3 times better than that on single server. Now, as I mentioned, single server is not going away. It is still a very cost optimized SKU, and it provides you a level of high availability built into the platform. But what's new in Flexible Server is that we are now making use of the availability zones that we have within the same data center region. We have several data centers. If one of those data centers goes down, with zone redundant high availability, you will have synchronous replication, i.e. high availability, to stand up the service in the other data center. So that's a very important capability. I mentioned custom maintenance windows, and another nice thing that we're doing with Flexible Server is we're providing PG Bouncer for connection pooling built into the platform as well. Next slide. When we talked about Hyperscale, I wanted to call out this technology because it's really a differentiator for Microsoft to be able to take Postgres and scale it not just vertically to scale up to bigger and bigger SKUs, but to also be able to scale horizontally. What you're doing here is basically you have a coordinator node that's keeping track of which data is landing on what worker node, and then you can scale those worker nodes almost limitlessly. We ourselves are using this service in Windows Update, and we're running 6 million queries on top of 2 petabytes of data, all within milliseconds of response time. So this is a very powerful way for your really large databases and your really high performance workloads to be able to bring them to Postgres as well. Couple of customer examples here and really focusing on the developer experience. Fractal is a great example who's got an application that they are continuing to develop, and they don't want to spend much of their resources focusing on the operational task of database management. So for them, it's a blessing to be able to leave as much as possible of those operational tasks to the platform so they can focus on building their application and continue to be competitive and differentiated with the application. JFrog, very similar scenario. They have really embraced Postgres because of the open sourceness and the extensibility of Postgres, and very much focusing on using that from a developer perspective. And again, they want to build application. They don't want to focus on spending too much time on the operational tasks. I mentioned Hyperscale, and I already talked to the Microsoft story here, so I'll just touch on the top one as well. This is the transportation in Helsinki in Finland. They moved off traditional Postgres, single-noded, to Hyperscale to be able to reduce some of the queries for traffic management that were taking up to 10 minutes. And by moving to the horizontal query performance that you get with Hyperscale, they've been able to reduce the time it takes to process these queries down to seconds instead of minutes. So really powerful technology, and really encourage you to look into that. BNY Mellon is another example who's also using Hyperscale in combination with Azure Kubernetes Service. To my earlier point, You never use a database in isolation, particularly not if you're a developer. So I really like this story and encourage you to go and check out the Microsoft Mechanics How We Built It story here, where they will talk through their overall architecture and why they decided to use Hyperscale to do the analytics that they're running and then run the application in microservices using Kubernetes. Very exciting story. Shifting gears back to MySQL and MariaDB, some of the most common use cases, as I touched on, is the fact that 9 out of 10 websites are powered by MySQL. Also, a lot of the packaged applications like Alfresco, WordPress, and Drupal, and in the space of e-commerce, Magento and Shopify, are fully compatible and leveraging on MySQL as the database of choice for these web and e-commerce platforms. We also see a lot of customers using MySQL for transactional workloads because it's a great way to ensure that you're doing secure payments and secure transactions. The other use case that we see a lot is anything cloud native. Of course, cloud native can mean a lot of different things to different people, but the other use case we see a lot with MySQL is gaming companies that are using MySQL today. And again, moving to that PaaS or database as a service to offload some of the operational overhead. So if you look at just a couple of examples, I talked about the importance of secure online transactions, and MySQL really have become an industry standard when it comes to transactions. So HSBC in Hong Kong is using Azure's MySQL service and again, Azure Kubernetes services to provide a pay-me banking applications. When a consumer does an online transaction, whether it's to pay for lunch or to pay their friends to split the bill after dinner, they use PayMe, and PayMe uses MySQL. We have a Microsoft Mechanics story here as well, which is also really interesting to look at all the different cloud native components that we're using on the Azure platform to enable this application. Next slide. I mentioned gaming, and I don't think you'll be surprised given that Microsoft now owns Minecraft, that we have moved Minecraft to the Azure MySQL service. The reason I wanted to call this one out here is because the link that I'm providing here provides a very detailed technical blog on how to go about doing a migration. And this migration scenario looks very similar, regardless if you're moving from on-premise, from IaaS, or from another cloud provider's database platform. So speaking of migration, there is a lot of different options you have, primarily 3, when it comes to how you go about migrating your existing MySQL and Postgres landscape to the Azure cloud. You can use the dump, restore, or import exports capabilities that exist natively in MySQL and Postgres. You can also leverage on logical replication. And finally, you can use the Azure Database Migration Service, which is a very well-established first-party migration service that helps you have a seamless migration experience. We have written very detailed documentation on how to do a migration. So you can check out the links here and you'll find probably 50, 60 page documentation on how to go about a MySQL and a Postgres migration exercise. It is really quite straightforward. Next slide. I also talked about Oracle and the fact that a lot of customers are looking at getting out of or reducing their Oracle footprint, and that the database of choice here is Postgres. We definitely see that as a very big trend among the large enterprises that we are speaking to. And for that reason, we decided to write a very detailed guide on how you can leverage on the free open source migration tool called Ora2PG that has been around for over a decade and has been used to complete thousands of migrations from Oracle to Postgres. In this guide, it will show you, first of all, Ora2PG can automatically migrate up to 70, maybe 80% of your stored procedures and schemas without any manual work. And for the remaining 20%, you can use this guide as a reference to see what do I need to change in my Oracle schema to make it a Postgres schema, and how should I change my query in Oracle to run well on Postgres. So this is a very, very good document to help guide you if you want to go down this journey on your own. We also have a lot of very capable partners, both from a tooling perspective. I would call out partners such as iSpire and Stream for online migrations, including the data migration, but also very strong system integrators partners such as Hexaware, Quadrant Resource, and Newt Global, who have done dozens of migrations, helping our customers have a seamless experience, leveraging on their own tools and methodology. Next slide. So we covered a lot today about open source relational databases, and I'm sure you're all curious about the big trend, which is NoSQL, and what you can do in terms of moving your Mongo and Cassandra on-premise clusters to database as a service as well. Well, I'm not going to dive deep into this, but as I mentioned, one of my colleagues is doing a session on Azure Cosmos DB as well. So I really recommend you look and check out that session. Now, I will just say that Cosmos DB is an umbrella platform for different types of NoSQL databases. And we support open APIs for Cassandra, for Mongo, and for Gremlin. We also have a managed instance experience with Cassandra that a lot of our customers choose who wants to have a seamless experience moving from Cassandra on-prem to hosting it in the cloud. And then you can take the next step towards the Cassandra API. Then we have our own two APIs. We have a table API and also what we call the core or the SQL API, which is slightly misleading given that the core API is our first party document and key value database. Next slide. So what are the key benefits then of running your NoSQL on Azure as a database as a service offering under the Cosmos umbrella? Well, first and foremost, it again takes away a lot of the operational tasks in terms of managing your clusters and the growing hardware requirements that you will see, particularly with the big data that these NoSQL databases tend to take care of. But we also offer 5 nines of high availability. If you leverage on our multi-region setups, we're really making the most of the fact that we have multiple data centers spread across the world. With that, we also offer you very low latency, below 10 milliseconds, guaranteed SLA-backed latency, and at any scale. And it's fully managed as well from a manageability perspective. It's again, you need to set up what's going to be the right partition keys and the right data model. But once you've gone through that work, the platform pretty much takes care of itself, certainly compared to the experience you would have and be used to on-premise. Next slide. Okay, so we covered a lot of ground in this session, and I know I was kind of rushing through a lot of this. So for that reason, I wanted to share some of the key references where you can go and learn more, whether that's about why you should think about database as a service in the first place, why Azure is a good place to run your open source databases, the value of moving to open source. I don't think it's a difficult conversation to talk about the TCO, but the operational benefits of leveraging on DBaaS is another important aspect. And we do have detailed technical white papers and TCO white papers to go through that if you need to work on how you justify that with the business. And I also have provided some links to that Cosmos side of the fence because it really is a lot to drill into, looking at 5 different types of databases, and also some migration guidance, both in terms of moving from Oracle, as well as moving your Mongo and Cassandra to Azure Cosmos DB. So with that, I have covered a lot of ground. I just wanted to close on the point again that we know everyone has their favorite database. I'm not going to try to convince you which database engine is the best. Whatever that database engine is, you can run it on Azure and you can run it on Azure as database as a service. Really hope that you enjoyed this session and it's given you some ideas of how you can focus on building your next application and make sure that it scales and that it's operationally easy to manage by making the most of our open source database as a service offering. So I'll close here and I would leave you with a video that will show you some more customer examples and case studies. Have a good rest of the day. Thank you for your time.